Let's start this lesson by trying to find a side given one side and one angle. So we create a right angle triangle where we have x for the hypotenuse, 5 for one of the straight sides, an angle of 30 degrees inside the triangle. We go back to our knowledge from Trig 1 and we label the triangle. I would recommend any time you're doing trigonometry, you write SOHCAHTOA at the top of every page. And this will help you remember what are called the trigonometric ratios for sine, cos, and tan. So we talked about in trigonometry 1 how h and a always touch off the angle. There's my angle. H is always the side opposite the right angle. And then O has to be 5. So what are we looking for here? We're looking for x, which in relation to HO and A is we're looking for H. And what do we have? We have O, which is 5. Now, by writing this down, these two letters, only one of these ratios has O and H. Can you see which one it is? It's sine. So this will tell us what ratio to use. So we're going to use sine. And we say that the sine of the angle is equal to O over H. Write that to the side. O is 5 and H is x. Or you could leave it as H. So now, if we just write this separately, sine 30 is equal to 5 over x. We looked at the sine of 30 in the last lesson, but we're going to leave it as the sine of 30 for now, and 5 over x, not 8. 5 over x. So, multiplying both sides by x, I'm going to get x sine 30 is equal to 5. Now, I want x on its own, so now I have to divide both sides by sine 30, so I'm going to get x is equal to 5 divided by sine 30. Now, you can type this straight into your calculator. You don't need to simplify it early in the question, because if it was the sine of 31, it would be a decimal. The sine of 30 is equal to a half that we saw in trigonometry 1. So if you type this into your calculator, you're going to get x is equal to 10. But I just want you to pause and look here for a second. If we have an equation, and the same thing will happen every time, if we have the sine of an angle and the unknown is on the bottom, all that happens is these two swap places. And that's what happens when you multiply across by x and divide across by the sine of 30. So get used to when it's like this, and then the next question, it won't be like this, but when it's like this, when the unknown is on the bottom, it swap places with the sine 30. So x is equal to 5 divided by sine 30, and you're going to use your calculator to get x is equal to 10. Let's have a look at another example now. So we set up a question that has cos ratio. Let's have the angle to 15 degrees. Let's say that we have h, which is 15 as well. Well, let's say 115, just so it's not the same number, and we call it meters. And h and a is the cos ratio. Just write SOHCAHTOA again. So you can nearly set up these questions yourself. And if you can set up these questions yourself, that's when you know you're brilliant at maths. Just create a triangle with two unknowns and work out the other variables. My right angle is here. So to set up a question with cos, I have to be dealing with the a and the h. And a and h always touch off the angle. So we're going to label this side as x. And now we're asked to calculate x. So again, we label our triangle. What touches off the angle? H and a, you all say. Leaves O over here, which we're not going to need in this question. We could get O using Pythagoras, which goes back to an earlier part of this question. So let's say we do want O. We'll work it out at the end of this question. So what do I have, or what am I looking for? I can write either one. I have H and I need A. So you can see here we set up a question with cos, A and H. So we write the cos of the angle is equal to, off to the side, A over H, so you don't mix it up. And in this case, it's going to be x over 115. So now the x is on top this time. In the last question it was on the bottom and it swapped places with the sine 30, but when it's on top we just multiply the left hand side by whatever's on the bottom. So 115 by the cos of 15 degrees is equal to x, and if you type that into your calculator, and you can type in 115 multiplied by cos 15 or just 115 and then press cos 15, your answer will come up as 111.08. Now if we were asked to round to one decimal place, that will be 0.01, so that's 1 dp for decimal place. The nearest whole number will be 111 and it's in meters, and that's whole number. So read the question carefully, identify what they're asking you, and then write your answer in the form that they want: one decimal, whole number, or two decimals. That would be two decimals. Now, let's say we did want this side here, the opposite side. It could be the height of a building when we go to real life questions. So if we draw a triangle out again, we now have two sides. We have 111 here, and we have 115 here. And let's call this y. Remember Pythagoras? So we want the straight side, we have the diagonal. So y is equal to the square root of the diagonal to be squared minus the straight side to be squared. And if we type this into our calculators, it will initially come up as y is equal to 2 by the square root of 226. Now this is what's called surd form, and we've seen that in another video. So you just press the change button on your calculator, or S to D or D to S, and it's going to come up as 30.066. And again, that would be, it's actually 0665, so that's 4 decimals. To 3 decimal places, that will be y is equal to 30.067. To 2 decimal places, it will be 30.07. To 1 decimal place, it will be 30.1, and to the nearest whole number will be 30. So 3 dp, decimal places, 2 dp, 1 dp, and to the nearest whole number. Let's look at a couple of more examples now. We'll use tan next. So how would I set up a question with tan in it? I'm going to need right SOHCAHTOA again. Can you see what tan has? Tan has opposite and adjacent, so it doesn't have the hypotenuse, which is diagonal. So to set up a question in tan, we use, let's use an angle of 50 degrees this time. It's the straight sides we're dealing with. Tan is the straight sides, and we're going to look at slope and coordinate geometry. The rise over the run is, we're going to think of tan as well when we think of rise over run. So it's the slope. Tan will give us the slope. So let's say that this one is x and this one is 20. What's the first stage in all of these questions? The first stage is to label your triangle. What two sides touch off the angle? H and A. And you can see I'm being consistent with how I approach every question. So O is the other side. So what do I have? And what do I need? I have A and I need O. And we said we were setting up a tan question. You can see that this is O and A. So use tan. And I would write this down in an exam. You're slowing yourself down. You're telling yourself what you're doing. You're showing the examiner what you're doing. So the tan of the angle, which is 50, is equal to O over A from up here. So write O over A to the side and then fill in what O is and what A is. O is X and A is 20. So the same as the last question, 20 tan 50 will be equal to X. And we just type that into our calculators, 20 tan 50, and we get an answer of 23.835. X is equal to 23.835. That would be 3 dp. 23.84 will be 2 dp. 23.8 will be 1 dp. And 24 will be to the nearest whole number. So I'm going to do 3 questions now. You're going to pause the video. One of them, the first one will be sine, the second one will be cos, and the third one will be tan. But I want you to do the work exactly the way I have laid it out here. And if you can get all three correct, you're confident enough to move on to the next lesson. So pause the videos, try these three questions, and then look at the solution and correct your solution. So hopefully you made a good effort at these. First question I said was going to be sine. Label your triangle. H and A touch off the angle, where H is opposite the right angle. O is the other side. So we have O and we need H. So we use sine. The sine or the sin of 10 is equal to O over H, which is 20 over x. And from the first example we saw today, x and sine 10 swap places. X is equal to 20 over the sine of 10. And if you type this into your calculator, you're going to get an answer of x is equal to 115.1754, so 0.175, 115.18, 115.2, or 115. 3dp, 2dp, 1dp, and whole. So when you're practicing these questions, maybe do all of these so that when you get to an exam and you see 3 decimal places, you know exactly what you're doing. In question 2, let's label our triangle. Now I've changed around where the angle was, and in the third triangle I've changed the direction of where the right angle is. Not to confuse you, but this is the type of thing that they will do in an exam. So that's H, and we can see that H and A always touch off the angle, which leaves O here. So we have H and we need A, so we use cos. So the cos of 60 is equal to A over H, which is equal to X over 25. So in this case, not like this one where we had to swap them. This one we just multiply the cos 60 by 25 and we'll get X. So X is equal to 12.5 because the cos of 60 is equal to a half. Now, that could be meters, it could be centimeters. You'll always be told in the question. So make sure you put the units in, which I haven't done so far in these questions. So the third question. Opposite the right angle is H. So H and A touch off the angle. You can say I always put those two on first. So this is O, opposite. So what do we have? We have A, and what do we need, or what do we want? We need O, so we use tan. Now when you get really good at these questions, you can eliminate this process and you can jump straight into the question, but until you get brilliant at them and you're 100% confident, write this information down. So we say the tan of 45 is equal to O over A. So O is 2 and A is X. So again, like question 1, this one here, they swap places, the A and the tan 45. So A is equal to 2 divided by the tan of 45. Or we could call it X. I've left it at A in this case. It's an unknown letter, so it doesn't matter. So you can use A, you can use X. It's up to you. So if we type this into our calculator, we're going to get A is equal to, and we're going to get an answer of 2. Now, how is it the same? How is this 2 and this 2? So this is just going to introduce something to you now. If this angle is 45 and this angle is 90, if this has to equal, this one and the 45 have to add up to 90. So this is 45 too. And this is bringing in isosceles triangles where the angles at the lengths of sides that are the same length, this one's 2 and this one is 2, the angles at the end of those sides have to be the same size, and that's where the 45 comes from. So you may have seen that before you started this question, but still show the maths involved. So hopefully you're confident that with these, finding sides when we have an angle and a side. In the next lesson, we're going to look at finding angles when we have two sides.